In this lecture, we are going to discuss the cross-site scripting attack, an attack which affects a lot of web applications around the world. So the cross-site scripting attack happens because a lot of web applications, they allow invalid data input on their web pages, such as discussion forums. So what happens is that the attacker, he creates a new thread, and instead of just inserting text messages and images, he basically also injects malicious code such as JavaScript. So when a new user, he visits that thread or that web page, in addition to the text that is there, the script is also loaded and executes. Now this script is malicious and it can basically steal users' session data and credentials. Cross-site scripting comes in two variations. The first variation is persistent or stored cross-site scripting. In this variation, the malicious code is stored permanently on the web page. So for example, the discussion forum that we just discussed, in this case, the malicious code is stored in a thread or a message permanently. So whenever another user visits that page, he's always going to get that script. In contrast, we have another variation of the cross-site scripting attack, which is called reflected cross-site scripting. In this case, the malicious script is included in the URL, and then this URL is disseminated to different users through emails, or they can also be posted on websites. And when the user clicks that link, basically the malicious script gets loaded, executes, and steals session data or passwords. So the two different variations are that the first one, the script is permanently stored. But in the second one, in the reflected one, the attacker has to actually send the malicious link to all the different users. So he has to keep on doing it. So let's start with the persistent cross-site scripting attack. In this attack, we have a normal discussion forum such as this, where users come and they post their comments, they create new threads. So every message in this discussion forum should normally be text message or images, right? So let's see what happens when an attacker creates a new thread. So basically he can put any topic and he can put any message, but inside that message he's going to insert malicious script. So normally, as we discussed previously, all of the web pages are basically HTML based, but you can use these tags, the script tags. So this tag starts the script and this tag indicates the end of the script. So within the HTML code, the malicious attacker can introduce this script, and then he can write any commands based on JavaScript here. And then this malicious message is committed, it's submitted to the website, which basically stores it permanently at the backend. And that is why this is called a persistent cross-site scripting attack. So now what happens is that when a user visits this page or this particular thread, he views this thread, but the malicious script also gets loaded and gets executed on the browser of that client. And that malicious code, it can do a lot of stuff. For example, it can steal session data, it can steal credentials, so all sort of stuff. So the overall flow was that the malicious attacker created a new thread, inserted malicious script inside that text message. And when the HTML renders that page, in addition to the standard page, this script also gets executed on the client's browser, steals information such as session data and credentials, and sends it to the malicious hacker, for example. Let's discuss the second type of cross-site scripting, which is the reflected cross-site scripting attack. In this type of attack, the attacker payload is included in the link, which is sent to the server and then reflected back to the user. Now the malicious link must be delivered to every individual, for example through phishing emails. This is in contrast to the persistent cross-site scripting, which was basically stored permanently at the back end of the website, so that whenever a user comes to that thread or that page, that script gets loaded. In reflected cross-site scripting, the malicious attacker needs to actually deliver these links to different users. So he needs to be active as long as this attack has to work. So the consequences of a reflected cross-site scripting attack are similar to the persistent one. It can steal session cookies, it can steal passwords and any other information such as your bank information, any other sort of credentials. Let's see how this works. So there is a user and we have the perpetrator, and here's the web server. So what happens is that the perpetrator, he crafts a URL which includes the malicious script. So if you notice here, he has included the malicious script right inside the URL. And then this URL is sent to the user. Now, users are normally not very careful. They don't actually see the full URL and they assume that it will be legitimate and they click it. So when they click it, now the attack happens in two steps. It doesn't happen directly. So when the user clicks this links, he's sent to the web server, and then this web server simply reflects back this string, and then this URL gets loaded into the browser of the user, and then it attacks the user, and which for example is stealing their credentials, stealing confidential information or session data. So this attack doesn't happen directly. The malicious link is sent including the malicious script. The user clicks it, and when it reaches the server simply reflects it back. And when this message reaches the user, the script gets loaded and basically executes on the browser of the client or the user and steals information and sends it to the perpetrator. So this is how the reflected cross-site scripting attack works. Now this is different to the persistent cross-site scripting attack, in which the malicious script is stored at the backend of the web application, and whenever a user visits that, it always gets loaded. In this case, the perpetrator has to actually deliver the malicious links, the malicious URLs to each individual user. Preventing the cross-site scripting attack uses a lot of similar approaches that we discussed for the SQL injections. So the first one is obviously user input sanitization. So we should have functions or methods which check for the presence of special characters, especially these angle brackets or keywords such as script. And our methods should ensure that these malicious strings are either removed or replaced with benign characters. Another approach which is different to input sanitization is user input validation. Now this basically ensures that any user content rendered to other users does not contain malicious code or scripts. User input sanitization is different from user input validation because the sanitization happens when the user is entering his information for the first time, whereas validation happens once the user data is stored at the backend and now it is being retrieved to be displayed to a different user. So before rendering that information, the web application should make sure that it does not contain malicious codes or scripts. Another nice technique is to use secure code reviews and using secure libraries. So basically, companies should always ensure that they have secure code review processes which check for entry points and test attack scenarios. So this is just like use case testing. So basically, we try different scenarios which can be exploited by possible attackers. We should also strive to use secure coding libraries such as OWASP-J. So by using a combination of user input sanitization, user input validation, secure code review, and by using secure libraries, cross-site scripting attacks can be mitigated to a significant extent. That concludes our lecture.